Witam wszystkich. Niestety muszę poinformować, że ten talk będzie po angielsku. A przepraszam, muszę jeszcze włączyć tutaj. Dobrze? Yeah.
But bear with me, it's better for you. It will be in English than in Polish. I suspect that last time when I gave my talk at the local meetup, then the organizers of the conference just asked me, could you do please your talk in English? Yeah, but because it's mostly I spent the last 20 years working in Paris, so I've dealt only with French and English. That's why every single Polish word from IT world, I was like, I don't know how you say that. Yeah, but today we'll be talking about solving temporal business problems with event sourcing and functional programming. How many of you have already used event sourcing or know about event sourcing and functional programming? Okay, so it won't be a big dive into functional programming. It will only serve a purpose for the event sourcing, and I will dive much more into the problem we had solving different business problems and why we've used functional event sourcing. So I'm running a small consultancy company in Paris, DTCO. I'm also one of the organizers of DDD Paris user group since 10 years. And I'm also involved in F# group in Paris. And lately I started to collaborate with Wolfgang Vernon on IDDD workshops in French and Polish. And also I'm contributing a lot on the Valingo platform, which is an actor model platform. And this is my Twitter handle. It's a bit small. I think that nowadays it's more important than the first and last name. But let's dive into the problem. So what's the business problem I'll be talking about? So one of the clients has called us and he had a really weird problem to solve. It's the company in asset management, in finance, and they have many temporal issues because they are all the time like dealing with different dates on different business concepts, and they cannot consolidate it very well. So they have a legacy system that is built like in the classical NTR architecture, and they solve this with an ORM thing and databases with historical tables, and it doesn't work very well. And we didn't want to work at all on the whole domain of the asset management, but the most important thing for them was the middle office, which was really a subdomain that held all the interactions between all the contexts in the company. And the only connection we had to care about was with the legal department, because they depended on them. So we had this from the domain-driven design, what we can say the conformist type of collaboration, when the middle office were depending on the legal part all the time. So every information we get from legal department has to be like treated and dealt with by the middle officers. And those informations was about financial instruments. And legal department like published information about financial instruments, and then this has to be managed by the middle officers. So they had all this information from the upstream legal department. And they had they had requirements like audit log for the change tracking, because in finance you have to track every change. You have to have a proof what changes were made on different instruments, and because you need to produce reportings, and for government or other financial organizations. And also they are interested in the kind of time traveling and querying. What was my state of the system at the time in the past? What should we have known at the time and what we knew at the time? This is really very important questions that we have to answer, and it's not very easy. You have to put the light on, I think, for the... You have to put the light... zapalić światło. A tak, nie? Ta. Proszę? A no... No ja nie wiem, ja to... No, to... jak sobie życzycie, nie? And answer time-dependent questions, so as I said. And why event sourcing? They didn't call us to say, oh, guys, I heard you are good at event sourcing and CQRS, you've made some of the projects. We were called for the business problem at first, and so we found out that event sourcing would be a very convenient architectural pattern to use. And like Greg Young said, who is like at the very beginning of CQRS pattern that coined the term CQRS, and he talked a lot about event sourcing. State transitions are an important part of our problem space and should be modeled within our domain. So for those that don't know event sourcing, I'll be doing a little introduction, very quick. So most of the problems we have, we store the current state of our application, like in tables, and we have the latest snapshot of the state. But this is not the only solution. We can store the state. What if we stored the state like the events that were happening that led to that state? Like, for example, if we take the account problem for private banking domain, we can deposit some amount of money and withdraw this. But first we have to open account, then we deposit some money, and then we withdraw a part. So at the end, for the account Tomasz, you can see that at the end you have 100 euros. That we don't care. But what's important is you can track all the operation that led to that state, and it's very hard to track this in the first example when you just store the snapshot. And the same for another account. You have 50 at the end, but we know that first he opened, deposited 150, withdrawn 150, and then deposited $50 again. So those are the events that are immutable. It means that those are the facts that has been recorded in your domain and cannot be changed. And how we discover that? This is something called event sourcing. That I think there was a event storming. That was the workshop before the conference. Those are the stickies of different colors. So you just go and you bring in all the stakeholders on the projects, and you explore the domain space and problems. And the goal of this exercise is not to find like a model that you will implement straight in the code, but it's defined like the events that are important to the business flows, commands and policies, business policies, and to define any bottlenecks or critical issues that are in your domain problem. So we have like orange sticky for a domain event, and domain event is a fact that someone has deposited some amount of money, and for domain event to happen, we need a business intention, which we call a command. So we want to deposit something, an amount of money, and as a result, if the command is executed, we will have this domain event that it's then recorded. And of course, we have what we call an aggregate. It's the business concept, the business object that takes as input a command and as a final state emits an event. So this is how it works. What we store is an event log, which is immutable. We cannot change the data. So we open, deposit 200, we withdraw 50, withdraw 100. But what if this is an error? Because you have no delete. You cannot just delete the state that is already in the event log. So in the simplest cases, you have the reverse operation, which is called the compensation. And if it should have been 150, it means you have to compensate on adding another event, which is withdrawn 50. And in the end, you will have the consistent state. But this is the very simple case. And in real business problems, it doesn't work like that. So some of the benefits of event sourcing, as I said before, like it's an audit-proof log. We have all the state changes that are recorded as domain events. And those, this is an append only, which is very good solution for distribution support. It's much more easier to integrate that in the distributed systems than other solution, architecture solution. And it's a natural fit for functional programming. This is where functional programming comes in. And I mean, why this is a perfect match? Because one of the concepts for me that it's very important that both shared event sourcing and functional programming is the immutability. And if you followed the Venkat talk this morning, mutable shared state, it's really evil. And I don't say that you have to use a functional programming language, but you can use functional programming patterns it will be in an object-oriented programming language to achieve some kind of immutability for the event-sourced projects. It will be much harder, but you can do this as well. And immutability is about data. So data you cannot change. If you want to change data, you have to produce a new data with the change in information inside it. And that's a very powerful concept, because you cannot just mutate data, and it does mean that for the concurrency problem, for everything that needs like parallel execution, it's far easier to deal with immutable data than with shared mutable state. And event sourcing, as event log is immutable, it's a perfect match. And some time ago, in 2013, Greg Young said, if you want to learn event sourcing, you just have one function. And this function does just take a state of your object and an event and produces a new state. That's really interesting. And one of my friends said that today you would he would call those functions. So the function that Greg Young is talking about is evolve. You take the state event and it produces a state, and we have to have another function which will decide what we do with the command that comes in to our domain object, which is decide command state, and we produce a list of events. Yep. Let's see how it looks like. If you had just like an account object that is your business concept, and you would do this in a classical way with the database on some kind of object relational mapper, you would just mutate some data in the object and you would just save it in the database. But with event sourcing, it's not quite the same. You have like a kind of command that comes to your function. The function decides if the command can be executed. And let's say you have to withdraw some money, and the function will decide if you can withdraw because you're either you have not enough money on your account, so we cannot execute the command, or you have enough money. And this is for that you need a state. You need what's the current state to take the decision. And if if the decide function takes the command in and decide that it can be executed, we produce a list of events that can be saved in an event store. And at the same time, this is passed over to another function which is called apply, which takes an event list and applies to itself in another function which is reply, and produces a new state which is then passed over to the decide function. And if you are restoring the initial state of the object, you have to replay all the events from the event store or event log, whatever, to your aggregate, which is, for example, the account object. So concretely, we want to withdraw 10. The decide function have a state of 50, so we can execute an event withdraw 10. We save this in event store, and then this event is called to apply, and the apply function just produces a new state inside the reply if you have a list of events, and those events produces a new state, which this time is state 40. And this is inside the account aggregate. And before that, the initial state is restored, like we had open, deposited 80, withdrawn 30, and withdraw 10, which is the 30 state at the beginning. So the decide function is really simple. And I don't know if you can see, this is F#, maybe it's not readable from the place where you are. But the key here is to understand that with those type of data structures, it's very easy to model the command, which can be of open account, deposit, and withdraw, with different data in it, at the same time to model the event, which can be either of opened, either of deposited, and either of withdrawn. And so we have an event either of those types that are listed there. And the decide function is in fact withdraw. So withdraw decides if we can withdraw the money or not. And as we can say, withdraw takes into the first parameter is the command. The second parameter is the state. And then we match the state with the current state of the account. And either the account is not initialized, so we cannot just withdraw, either it's active, but the amount we want to withdraw is less than 0, so we cannot do that operation either, or it's active, but we want to withdraw more than we have on account. So all those states are rejected, and finally, the last one, we produce an event, which is the new state, and the interesting bit, it's the current balance we can put into the event, which is the calculation of the current balance minus the amount of withdrawn. And this is the very simple case. It works like that. And the same for the apply. We have the same pattern matching the state at the beginning and the event that we want to deal with. And then we deal with different cases. If it's either initialized and opened, we change the state of the account. It's the apply function that changes your state. The decide produces an event, and based on the event and the current state, we can evolve. We can evolve the state of our object. And yeah, so those are the different cases. And for example, the last one, if we have an active account and the decide function in the step before produces an withdrawn event, we have a new state that is produced for our account, which will adjust the balance here. This is the current balance minus the amount that was matched in the event. Okay. So the reply function is just another one that will just loop over the apply function, and it just this sequential fold over the state with the different events to apply. So all those patterns in functional programming match very well the problem domain that we have to solve very elegantly. That's why I think it's far easier to develop with functional patterns than with the traditional way. But here we have a business problem, because we have to talk about BI-TEMPORAL. We just saw a bit of event sourcing, how it works, the very basics, but the problem we were called in was about a different thing. So let's say we have those events, and if we look at the date of 28th of February, which is here, we say that the balance is 0, because we have deposited 150 and withdrawn 150. And the business say that the balance should have been at 50. But what we have in an event log is different. We say, no, it's 0. And they said, no, it's 50. And we've been exploring the problem that they have. And they say, can you fix the past? Right? Because we know that at the time the balance is false. And that's why there is something called BI-TEMPORAL event sourcing that can help us to solve the problem. And it's a new way of looking on the data. And the first example that we have that shows that we have 0 on the balance and should have been 50, we can model it differently. BI-TEMPORAL event sourcing, you have 2 time axes. So the first is the record time and what we have in the classic event sourcing, and the second timeline is the validity time of an event. So we can have those events that points on the validity time, which is the same. Very interesting. But the deposited, the last event, its validity time, it's before the date at which we observe. So now, if we take the validity time, we have 50 on the balance. That's very powerful pattern in finance. And why is that? Why someone would have an event that is recorded in March and it's valid on February? Because recall that we are at this kind of collaboration, and the legal department is giving informations to middle officers a bit late. So the time the middle officer records an event that has happened, the event already should apply in the past, not at the date that was recorded. So they are all the time like catching up the train, and we have to deal with that. And those are called like as of and as at kind of projections of your object. It means that as at, it means what was the state at that date, and as of, it's what should have been the state at that date. And if you combine both of those, you can have a very powerful queries on the state of your objects. So as at 29 February, we had 0 because we look at the record time. But if the record time is like now, today, and what we know today and should have known at February is that the balance should have been 50. And so yeah, this is the simple scenario of bitemporal event sourcing, because of course when you deal with different business problems, they have like a bigger problems to solve. So this query says that as of what should I have known at February with the information that I know in March is that balance is 0. But if we switch the dates, we can play on different views of the data. And once you know that, when you start to implement this with the functional patterns, it's just very simple, because you can use all the functions like replay you had before. And what you have to do is to take a date into account and filter out all those events before you replay the current state of your concept, of your object. Yeah, you play the initial state and you are done. And the same thing for another projection, which takes 2 dates, as a recorded date and validity date, as of and as date. So yeah, I won't go into details, it's not so important, but what we have, it's a sequence of operations that is filtering and sorting. And the code, I mean, it's readable for those that knows the syntax, but once you start to learn, it's not so hard to understand. And then you have to load the current state of your account, and the same way you have very powerful patterns to match on what kind of projection you would like to do, and what kind of projection can be determined on the command that you send in. If your command contains 2 dates, you would like to choose either of as of or 1 date as at. It depends really on different cases. And for example, in F#, what we have, it's called the active patterns that will somehow help you to reduce the boilerplate of your code. And like in the load function on the top, you just use now, as, at, and as of all the consideration on calculating if we are now as at, as of, it's contained inside the active pattern. So yeah, I'm sorry for those that don't read the code very well, but I believe it's the last slide with the code. So there were many bitemporal event sourcing patterns that we had to somehow find out because of the different business cases. So just for information, bitemporal, it's not something that was invented with event sourcing. Those temporal queries in the domain are known for a long time, and there are some databases that already implemented those type of patterns. They are even tri-temporal, so we have 3 time axes, like for example another one for the decision time. So you have validity, decision time, and record time. This is really weird, and it becomes very hard to reason about. But let's say we had a situation with backdating. This is something that we've talked already. So you say that you record a deposit of 50 on a date, but in the date, validity date in the past. So this is the easy one. Now it's the I that it's at the end of the time axis. Then forward dating, it's another operation that you can do that. Now back patching, you can say that we have an event that is recorded, but we found out that the date of validity is not correct one. We want to change the validity date, so we emit another pattern event which is patched occurred, which points to the event that we want to change, and that event will have another validity date. So this is not, like I say, a mutation that I'm doing here, because events are immutable, as I said. So you have to find out a way in a code to just treat the event which is like deposited and the matching patched occurred event if there is one, and to apply the new date on the fly when you are querying. And another one is forward patching. So the same, but in the future. And another one is event cancellation. It seems weird. It's nothing to do with delete operations at all. But there are some queries and some views that the business people just don't want to deal with that. So you can say that you are canceling an event. So when you are replaying the validity time axis, it's the event like it never existed. And however, you still have this event in your log, so we can track and find out what has happened. And also, what do you do when you have an event in the future? So that's really weird. But what we've been doing, it's like scheduling a command in the future, because the command can be scheduled, and the command was scheduled, for example, for 21 of June, and at the 21 of June we will just execute the command, and it will just flow the normal execution flow of your aggregate. But there are some things to take into account, because a command can be sometime in the future just rejected. If your business logic has changed in the meantime, it can be rejected. And there is another problem. It's we cannot just patch this scheduled command in the past, because it would mean that, yeah, there are some inconsistencies. Another problem I didn't talk about, we were seeing canceling, patching, and the stuff like that, but we find out that business people were doing so many, they were correcting so many data that we had in the stream like canceling a cancelled event, which is like different to find out what's the final state, but or patching many times the different dates on several events, or patching an already patched event. Well, and the future events, it's something very strange, because one could say, why scheduling a comment? You can just say that it's deposited now and it will be valid in the future. But yeah, this is not something I would advise to do. But it depends really on how you look at your domain, and I like, to break my assumption about what I already know. So why not considering that? If we consider the record time, let's say we have deposited this amount of money, and when we replay the validity axis, we just don't see the event at all. So it kind of holds, but when you move it now in the future, now everything is okay. It's just forward dating event. But yeah, this is like experimental, and I don't advise to use it. But if we just applied all of those patterns, it would be really easy. But you can have stream inconsistencies if you don't really look how it should work. For example, we have those kind of events, and we are patching withdrawn event with the backdate. We have a stream inconsistency because we've opened an account, and now we say that withdrawn is before deposited, which is quite impossible if we take into account the business rules. So we have to deal with those kind of problems. And also causality violations. If you have, for example, a rule that says that if someone has deposited more than 30,000 euros, let's award him a VIP role. But if you cancel this deposited amount because it's a mistake, and you still have a VIP rewarded event, it's like inconsistent in a time. And you can say that, like, for example, in real life, if someone could travel back in a time, and it traveled in a time that his own father was not born yet, and he killed his grandfather, so this situation couldn't even exist, because if he killed his grandfather, himself, he couldn't be here. So those are the causality violations. And another one is a casual loops. It's like you don't know which one of the events lies in your stream, because you have the events that are dependent one from another, and it's like you change the rewarded event, and you don't know why you don't see it, because you have deposited this event. And another, how to say, it's very difficult to find an example, but let's say you have a mathematician that found a proof of something, and you travel back with this proof to this mathematician before the time he found it. It's like the proof came from nowhere. It's the same kind of situation we have here. Because VIP rewarded event came like of nowhere, because it's before deposited event of 50,000 euros. And this is very interesting from the intellectual point of view, because these retroactive paradoxes, they exist in other kind of domains, but they deal with that like in parallel universes. You can try to implement like the parallel universes in your code if you do some kind of time traveling in the past. You're opening like a new universe. It's like you would open a new branch on Git and do stuff different like it would live its own life without merging at the end, or you merge, but under some condition of self-consistency. You can check and not permit to execute some of the backdating, forward dating commands. You can just say that if this will lead to a paradox, I just don't allow to do that. But it's very complex, because if you're backdating an event, the logic has already been run, so you have to find a way to replay the logic and to know if this event can be applied. Or for example, a creative avoidance, it's another one. It's like saying that, yeah, if I travel back in the past to kill the grandfather, maybe the grandfather is not the real grandfather of mine, because it's, you know, if just yeah, someone else, you just find different explanation of what you have in your stream, but this becomes very difficult. And yeah, that's the end. So the temporality is very hard and depends on your business problems, and business people like deal this on daily basis. And from the implementation point of view, event sourcing, it's a very good match when you would like to apply functional patterns. If you like functional languages, that's even better, but you can do also with object-oriented language and functional patterns. And the fact that you have all the events that has been recorded in your past, from one point of view, you have those powerful queries that we can run on your system, but also from the business perspective, you could have a new use cases that has not been recorded yet and explored in a different ways. And but yeah, event sourcing and all this stuff that brings a lot of accidental complexity, so it's very hard to deal with. And just apply this to the no trivial domains when really there's a need for this kind of solutions. And some references I've used in the talk. So the code samples I've shown in slides is the first link. Then there is a really interesting project made by my friend Finn Bishon Coding, FS Uno. It's a game implemented in event sourced and F#. You have a production also version with event store and all that stuff like that. There is an interesting talk from DD Exchange by Greg Young answering questions. It's like sending a message in the future. There are those temporality questions that are answered, and all the samples with grandfather and the stuff like that. There is a very interesting paper enabling retroactive computing through event sourcing, and they had a similar problems, but they've implemented it like with the parallel universes, quite different implementation from ours. But there's no many papers out there dealing with those kind of problems, so many of those patterns we just found out ourselves, and some of them came from the paper. So thank you for your attention. I think we are running out of time. Sorry for that. But I'll be hanging out, so if you have any questions, just please see me. Thanks.